Hi guys, today we'll be reviewing the mock paper that you have done on the 8th of August. So first, let's look at the first question. Alright, the first question asks us to express this as its simplest form. Okay, before we even jump into the question, let's analyze our two fractions given to us. When I see b squared minus 1 in our numerator, the first thing that should come to mind will be your algebraic identity, a squared minus b squared, where a squared minus b squared equals to a minus b multiplied by a plus b. Alright, if we look at the denominator of our first fraction, it is a quadratic equation. Okay, so what comes to mind should be factorization. Okay, alright, if we look at the numerator for our second fraction, okay, we will identify this as a quadratic expression, but on top of that, we can also identify this as a squared plus 2ab plus b squared. Okay, what is that? That is another one of your algebraic identity. A plus b squared equals to a squared plus 2ab plus b squared. Okay, and if we look at your denominator of your second fraction, we are able to do cross factorization, or rather we can do grouping. Okay, grouping, factorization by grouping. Okay, so if I annotate this over here would be factorization by grouping. Okay, now that we have analyzed our denominator, numerator of both of my fraction, let's go on and do it. Alright, so for our numerator for our first fraction, I can factorize this as a multiplied by b plus 1 multiplied by b minus 1, following the algebraic identity in orange. Okay, and for our denominator, let's do cross factorization. Okay, so I will have 2b squared here, I have negative 1 here, negative b here. Okay, 2b squares, factors of 2b squared, very straightforward, 2b and b. Factors of 1 would be 1 and 1. Here comes the trick. We don't know where to add our negative sign, okay? So before we even add our negative sign, let's just move on and multiply the factors. Okay, so I have b, I have 2b. Okay, so what relationship between b and 2b would give me negative b? It is where I have the negative sign in front of my 2b, right? b minus 2b gives me negative b. Therefore, my negative sign in my factors for 1 multiplied by 1 to give me negative 1 should be here. Okay, so I have factorized it successfully. I have 2b plus 1 multiplied by b minus 1. Okay, we have done our first fraction. Let's move on to our second fraction. So remember the algebraic identity that I've written in dark blue, this one over here. We can go on and factorize it. So now in this case, our b is 1, okay? So I would have a plus 1 squared, all right, for our numerator for our second fraction. And for our denominator for our second fraction, let's do factorization by grouping. So when I study the first two terms, I realized that both of them has a common factor of a. I'll factorize out a, I would have b plus 1, okay, plus b plus 1. So when I look at this, it is quite straightforward that in these two terms now, I have a common factor of b plus 1. So I'll go on and factorize it out. Alright, just give me a moment while I copy down the rest of the equation. Okay, so when I factorize out b plus 1, I would be left with a plus 1. Okay, so once we have reached here, it is pretty straightforward. We can just cancel out the common factors in our numerator and denominator. So let's go on and study this expression. So I will realize that I have b plus 1 in my numerator and I have b plus 1 in my denominator. So I can go on and cancel it out. I will also realize that I have b minus 1 in my numerator and b minus 1 in my denominator. So I can cancel it out. Okay. Lastly, I realize that I have a plus 1 in my denominator and a plus 1 squared in my numerator. So I can cancel out the a plus 1 in my denominator and I can cancel out the square in my numerator. Okay, so now we have reached the simplest form. Okay, let's write down all of the expressions that are left behind after all of the cancellation. I have a multiplied by a plus 1 divided by 2b plus 1. Okay, by studying this expression, can I further simplify it? No, I don't think so. So this is the simplest form, okay, which is my final answer for question 1. Alright, let's move on to question 2. Okay, now looking at question 2, they want me to factorize the following expression completely. Okay, just to make my working a little bit more, a little bit neater. Okay, I'll write my answer in part A in blue, I'll write my answer in part B in green, and I'll write my answer in part C in orange. Okay, so let's go on and look at part A first. Okay, right off the bat, before we even do anything, let's study the terms. Okay, I'll realize that in this bracket over here, I have b squared minus 2bc plus c squared. Does it look very, very familiar? Yes, it does, right? When you see this, you need to think of the algebraic identity. A minus b squared equals to a squared minus 2ab plus b squared, which is exactly what we have, but now instead of a and b, I have b and c. Okay. So let's go on and factorize this. So I have a multiplied by b minus c squared minus 2 times b minus c. Okay, so right now this expression is split into 2 terms. I have one term over here, subtracting one term over here. Okay, so I can factorize out b minus c. Okay, since in both of my terms I have a common factor b minus c. Alright, so when I factorize it out, what do I have? I have b minus c multiplied by the leftover factors, which is a multiplied by b minus c minus 2. Okay, so this is the simplest form that I can find. But of course, I wouldn't express my answer in this form. I would expand out the second bracket. So I have b minus c multiplied by ab minus ac minus 2. Alright? Okay, so this is my answer for part A. Let's look at part B. Okay? So right off the bat, what do we see? Okay? We have two expressions, x squared, y squared. Okay, so with that, I can think, oh, maybe it's a quadratic expression. But if we look at the next 2 terms, there is no terms with x, y, right? So this is a clue that maybe it is not that simple. Okay, so what if I study the next 2 terms, I realize that I have 8y and a numerical. Okay, so by splitting my expression, I realize that this bracket over here looks a lot like a quadratic expression. So why not? Let's go on and factorize this instead. So I have x squared minus. Okay, now when I want to add a bracket, I need to be very careful because what I'm doing is I'm factorizing out the negative sign. So when I factorize out the negative sign, I will have y squared plus 8y plus 16. Okay, and then from here onwards, there are 2 ways to go about doing this question. Okay, we can factorize out y squared plus 8y plus 16 using cross factorization. I can also use algebraic identity. Okay, so for students that are more familiar with algebraic identity, they can recognize this as y squared plus 2 multiplied by 2 multiplied by 4 multiplied by y plus 4 squared. Alright? Okay, so that will give me x squared minus y plus 4 squared. Okay, what about students that are not very familiar with algebraic identity? No problem, you can do cross factorization. Alright, so I would put in the respective terms. Okay, so of course factors of y squared, y and y. Factors of 16, I have 4 and 2 and 4 and 4 and 8 and 2. Alright, in this case, since I want my addition of terms to be 8, I would choose 4 and 4. So I have 4y and 4y, which gives me the same answer, 4 plus y squared. Okay, so with this, is this the most factorized form? Not really, because when I look at this, it reminds me of something. It reminds me of the algebraic identity, a squared minus b squared equals to a plus b multiplied by a minus b. So what do I have over here? I would have x minus y plus 4 squared, x minus y plus 4 multiplied by x plus y plus 4. Okay, to simplify my expression, I would have x minus y minus 4 multiplied by x plus y plus 4, which is the most simplified form for part B. Alright, next let's look at part C. Okay, by looking at part C, we have 4 terms. Alright, although we have 4 terms, but none of the 3 terms combined looks like a quadratic expression. Okay, so that is a clue that maybe I should do factorization by grouping. Since when I study the first 2 terms, if I were to factorize out 5x, I would have something that looks like 2x minus 3y. Alright, so let's go on and do what I have analyzed. Okay, so let's try. Alright, so I'll factorize out the common factors of my first 2 terms, which would give me 5x. Okay, and I'll be left with 3x minus 2x. Okay, plus 2x minus 3y. Alright, by studying the 2 terms in my bracket, my terms in my bracket looks the same, but the sign in front of my terms are different. Very simple, I can just factorize out a negative sign. Alright, so if I factorize out a negative sign, allow me to just factorize out the negative sign in my second term. Okay, so if I have a minus over here, minus gives me plus, minus gives me minus. Alright, and if I were to rearrange my terms, I realize that I have a common factor of 3x minus 2y. So let me go on and factorize this. So I have 3y minus 2x multiplied by 5x minus 1, which is my final answer. Okay, I hope you understand question 2. If there are no questions, we can move on to question 3. Okay, question 3 requires us to solve the equation. Okay, but before solving this, okay, some students, when they see this, oh, okay, I need to expand my brackets and I need to shift my terms around and isolate out y. But is there a simpler way to do this? Okay, yes, I understand that squaring a factor is very, very tough and tedious. I agree with you. So what if we were to do substitution? Okay, so let's 3 plus 5 over y be, let's say, u. Okay, so if I do a substitution this way, can I rewrite my expression as u squared equals to 30 minus u? I could, right? And with this, is this much simpler to solve? Yes, I think so. So when I have this expression over here, straight off my mind, yes, it's a quadratic expression. Let's do factorization. Okay, so I have u squared plus u minus 30 equals to 0. Okay, if I do cross factorization, I will put in the respective terms. Okay, factors of u squared, very straightforward, u and u. Factors of 30, there are a few, 1 and 30, 2 and 15, 5 and 6, 3 and 10, right? What relationship between my two factors will give me a difference or an addition of u? Okay, very straightforward, 5 and 6. Okay, so I will put 5 and 6 here. Before I even allocate my negative sign, let me just multiply it out. I have 5u and 6u. To get u, do I place my negative sign in front of 5u or in front of 6u? Okay, we will put it in front of 5u. So if I have my negative sign in front of 5u, of course my negative sign will be in front of 5. So I have successfully cross-factorized it. I have u minus 5 multiplied by u plus 6 equals to 0. So therefore I have u equals to 5 or u equals to negative 6. But is this the end of the question? No, I need to find y, right? What have I substitute y with? Sorry, what have I substitute u with? Okay, so let me substitute it back. Previously I said that 3 plus 5 over y equals to u. So let me replace it. I have 3 plus 5 over y equals to 5. And I have 3 plus 5 over y equals to negative 6. Okay? I'll continue my working on the right hand side of the screen. So let's shift my numericals. I would have 5 over y equals to 2. Therefore, y equals to 5 over 2. Or I have 5 over y equals to negative 9. Alright, therefore y equals to negative 5 over 9, which is my final answer for question 3. Okay? If we are alright with this, let's move on to question 4. Solve the equation. Okay, so before I even do anything, to solve an equation with factors, first I need to combine my factors, right? It is not so straightforward where I have two individual factors on the left side and on the right side of my equal sign. I have two fractions on the left side, so I need to combine them first. But my denominator consists of x. Okay, I cannot find a highest common factor or lowest common multiple for my denominator. So what can I do about this? Okay, when I have an expression with x, always factorize first. Okay, and hopefully my denominator of my second fraction, 12 plus 5x minus 2x squared, would be x minus 4 multiplied by 2x plus 3. But we cannot assume. We need to do it. Okay, so let's go on and do it. Okay, factorizing 12 plus 5x minus 2x squared. I have negative 2x squared. I have 12. I have 5x. Alright, factors of negative 2x squared. Before I even allocate my sign, let me just find the factors of 2x squared, which is very straightforward, 2x and x. Okay, what about factors of 12? I have a few. I have 3 and 4, I have 2 and 6, I have 1 and 12. Alright, what relationship would give me 5x? Okay, I think most probably what would give me 5x would be 3 and 4, okay, where I take 4 multiplied by 2, I have 8x, and when I take 3 multiplied by x, I have 3x. Alright, so the last step would be to allocate my sign. Okay, since 3x and 8x, if I want to have positive 5x, I would allocate my negative sign in front of 3x. So that would mean that I will allocate my negative sign in front of x. Okay, so I have successfully cross-factorized. Okay, my equation can be simplified to 2x plus 3 multiplied by negative x plus 4 equals to 4 over 2x plus 3. Okay, so by studying the expression that I have, yes, it looks pretty similar, but what is different is again the sign, right? I have x minus 4 and I have negative x plus 4. So how do I go about making the signs uniform? Okay, I can factorize out a negative sign. Okay, so when I factorize out a negative sign, okay, I have negative 2x plus 3 multiplied by x minus 4 equals to 4 over 2x plus 3. Okay, so once I have this, I know the common factor or the common multiple between my three fractions would be 2x plus 3 multiplied by x minus 4. Okay, so can I just multiply this throughout my expression so that I can eliminate all of my fractions? Yes, I think I can. All right, before this, the negative sign over here, I'll just bring it out so my plus becomes minus. All right, then my next step would be to multiply 2x plus 3 times x minus 4 throughout my entire expression. Okay, so when I do this, I eliminate my fraction. 2x plus 3 times x plus 4 multiplied by 3 over x plus 4, I get 3 over 2x plus 3. Okay, 2x plus 3 multiplied by x plus 4 multiplied by x plus 5 over 2x plus 3 multiplied by x plus 4, I have x minus 5. Okay, don't forget your brackets because it is very important. All right, as the sign in front of my fraction is a negative sign. Okay, 2x plus 3 times x plus 4 multiplied by 4 over 2x plus 3, I have 4 multiplied by x minus 4. Okay, with this, let's simplify my expression. I have 6x plus 9 minus x plus 5 equals to 4x minus 16. Let's isolate out the terms with x, okay, where I have 5x minus 4x equals to negative 16 minus 5 minus 9. All right, where I have x equals to negative 13. Okay, which is my final answer for question 4. All right, let's look at question 5. Question 5 requires us to solve the simultaneous equation. Okay, right off the bat, I have two equations. Okay, one of them is a quadratic equation, one of them is a linear equation. So maybe I can use my linear equation and do substitution to help me with my quadratic equation. So I have y plus half x minus 5 equals to 0. All right, so that will give me y equals to 5 minus half x. Okay, so let this be the first expression, let this be the second expression. So let's substitute my first expression into my second expression, where I have x minus 1 squared equals to 2 multiplied by 5 minus half x plus 1 squared minus 40. Okay, with this, let's try and simplify my expression. So I have x minus 1 squared equals to 10 minus x plus 1 squared minus 40. Okay, what do I have? Let's simplify. I have 11 minus x squared minus 40. Okay, so from here, I cannot escape from expanding my expression. Okay, so that would give me x squared minus 2x plus 1 equals to x squared minus 22x plus 121 minus 40. Okay, so to simplify my expression, I have x squared minus 2x plus 1 equals to x squared minus 22x plus 81. Alright? Okay, so let's shift all of my terms around. Yes, I know that it is a quadratic expression. So do I try and isolate out my terms with x? No, I try and isolate out all of my terms to one side and equate it to 0. Okay, so I have 0 equals to x squared minus x 0, negative 22x plus 2x 20, negative 20x, 81 minus 1, 81. Alright, okay, so from here I have a linear expression. So I isolate out my term with x. So I have, 80. So I have 20x equals to 80, x equals to 4. If x equals to 4, sub x equals to 4 into equation 1, I have y equals to 5 minus half times 4, which equals to 5 minus 2, which equals to 3. So I have successfully solved for x and y. Alright. Alright, let's look at question 6. Question 6 requires us to simplify this entire expression. Okay, so let's go on and simplify. Okay, when we look at the numerator of my first fraction, I would realize that, okay, what in this rule should I use? I should use a to the power of m to the power of n equals to a to the power of n times n. Alright, so that would give me q to the power of negative 4 multiplied by r to the power of 8. Okay, then when I look at my denominator, okay, square root, so that would simplify to the power of half. So I have q to the power of negative 2, r to the power of 4 to the power of half. Then to the power of 3. Alright? Okay, if I further simplify this, I would have q to the power of negative 4, r to the power of 8 over 2 to the power of 9 multiplied by q to the power of negative 1 multiplied by r to the power of 2 to the power of 3. Okay, next let's look at my second fraction. For my numerator, I have a very complicated expression to the power of 0. So when I have something to the power of 0, that would just automatically give me 1. Okay, and also I can choose to bring in my power negative 4. So I have 1 to the power of negative 4 over 2 to the power of 2, q to the power of negative 2, r to the power of 1 over 8 to the power of negative 4. So that simplifies to 1 over 2 to the power of negative 8, q to the power of 8 and r to the power of negative 1 over 2. Alright, okay, so from here we can go on and merge our fractions. So we have q to the power of negative 4, r to the power of 8 over 2 to the power of 9 multiplied by 2 to the power of negative 8 multiplied by q to the power of negative 3 multiplied by q to the power of 8 multiplied by r to the power of 6 multiplied by r to the power of negative half. Alright, and that will give me q to the power of negative 4, r to the power of 8 over 2 to the power of 1, as 9 plus negative 8 gives me 9 minus 8, which is 1. Alright, q to the power of negative 3 multiplied by q to the power of 8 gives me q to the power of 5, and r to the power of 6 multiplied by r to the power of negative half gives me r to the power of 11 over 2. Okay, so let's further simplify. I would have 2 half multiplied by q to the power of negative 9 multiplied by r to the power of 2 and a half. Okay, so that is my final answer. Okay, since the question asked me to express my answer in positive index form, so I will express my answer this way. Okay, so this is my final answer for question 6. Alright, let's move on to question 7. Question 7 tells us that a dealer bought X pens for $27. For part A, he proposed to sell each pen at a profit of 50 cents. Okay, write an expression in terms of X in dollars for his proposed selling price for each pen. So first we want to find the cost price. Alright, so the cost price would be 27 divided by X. Okay, so the price that he would be selling at would be 27 over X plus a 50 cents profit. Okay, so that is the answer for part A. The proposed selling price would be 27 over X plus 50 cents. Okay, for part B, he found that he was only able to sell 8 pens at this price. He sold the remaining pens at $2 each. Write an expression in terms of X for the total amount he had received for selling the pen. Okay, so if you have X pen, he sold 8 pens at the price that we have determined in question. The dealer sold 8 pens at the price we have determined in part A, so we take 8 multiplied by the price we have determined in part A. Okay, and the rest of the pen he sold at $2 each. So I multiply 2 by the amount of pen he has sold. Since the total amount of pen is X and he has sold since the total amount of pen is X and he has sold 8 at the previous price, the remaining pen would be X minus 8. Okay, so let's further simplify this expression. We have 216 over X plus 4 plus 2X minus 8. We simplify to 216 over X plus 2X minus 4, which is the answer. Alright? Okay? Oh, sorry. Times 2 minus 16. Okay? So, we have negative 12. Alright? Which is the answer for part B. Okay? And for part C, given that the dealer received $30 altogether by selling all of the pens, form an equation in X and show that it reduces to X squared minus 21X plus 108 equals to 0. Okay, so he has sold all of the pens, which is the equation we have found in part C, and the total amount received is 30. Okay, so our goal is to simplify this expression to a quadratic expression. Okay, so we can multiply the entire expression by X. Alright, so we have 216 plus 2X squared minus 12X equals to 30X. Let's bring my 30X to one side. So I have 2X squared minus 42X plus 216 equals to 0. Okay, and I realize that all 3 of my coefficients is a multiple of 2, so I simplify by dividing 2 throughout the entire equation. So I have X squared minus 21X plus 108 equals to 0, which is what the question requires us to show. Okay, and for the last part of the equation, they want me to find the possible values of X, which basically is asking me to solve the equation. Okay, so the equation is X squared minus 21X plus 108. Okay, so I will do a cross factorization. X squared, 108, negative 21X. Okay, X squared I have X and X. 108 is a factor, 108 is a multiple of 9 and 12. So I will place them there. Okay, so I have 9X and 12X. Okay, but I realized that the equation has negative 21X. So I'll put negative in front of both of my terms. Okay, since negative 9 multiplied by negative 12 still gives me the positive 108. Okay, so I have X minus 9 multiplied by X minus 12 equals to 0. Therefore, X equals to 9 or 12, which is my final answer for question 7. Okay? Alright, let's look at question 8. Question 8 shows a sketch of a quadratic curve with the equation given. They tell us that the curve cuts the x-axis at -1, 0 and at point P, and they cut the y-axis at point Q. For part A, they want to find the coordinates of point P and Q. Alright, to find the coordinates of Q, it's pretty straightforward. I just have to substitute x equals to 0. So I have y equals to negative 0 squared plus 5 multiplied by 0 plus 6. Therefore, y equals to 6. Therefore, coordinates of Q would be 0, 6. Alright, to find the coordinates of point P, first we have to solve the quadratic equation. We have the quadratic equation negative x squared plus 5x plus 6. Alright, so to solve it, let's do cross factorization. So we would place the terms respectively. Okay, x squared, factors of x squared will be x and x, factors of 6, 6 and 1. Let's not allocate the sign first. 6 multiplied by x, 6x, x multiplied by 1, x. Okay, then next let's look at the relationship between 6x and x. What would give me 5? It would be if I were to put my negative sign in front of x. Okay, so that would mean that my negative sign would be here. Okay, so factorization of this would be 6 minus x and x plus 1 equals to 0. Therefore, x equals to negative 1 or 6. Hence, coordinate of P would be 6, 0. Alright, this is the answer for part A. Next, let's look at part B. Find the equation of the line of symmetry. Okay, to find the line of symmetry, very simple. We just have to find the 2x intercept. We just have to find the 2x intercept and find the middle point. Okay, so in this case, it would be 6 minus negative 1 over 2, where I would have 3.5. Therefore, the line of symmetry would be x equals to 3.5. Okay. Next, let's look at part C. Part C tells us that a straight line cuts the curve at point M. Given that the coordinates of the point M are 3 and M, calculate the value of M. Alright, so the line cuts the curve at point M. Okay, so point M also lies on the curve, so very simply we just have to substitute x equals to 3 into the equation. So we have M equals to negative 3 squared plus 5 times 3 plus 6. So I have negative 9 plus 15 plus 6. Alright, so I have 12. Okay. Alright, so M equals to 12. Okay, the last part of the question. Given also that another straight line y equals to x plus h passes through M, calculate the value of h. Okay, so if we study the expression, y equals to x plus h, okay, we know that the gradient of this line is 1. We know a point on the line to be 3 and 12. So to find h, very simple. I just have to substitute in the x and y value. So I have 12 equals to 3 plus h equals to 9. Alright, and this is the answer for question 8. Alright, let's look at question 9. Now, instead of a negative quadratic curve, we have a positive quadratic curve. Again, they tell us the equation of the curve. They want us to find the x and y intercept. So to find r, it's very straightforward. I just have to substitute x equals to 0. So y equals to 0 squared plus 2 times 0 minus 8. So y equals to negative 8. R equals to 0, negative 8. Okay, to find P and Q, I just have to solve the equation. So x squared plus 2x minus 8 equals to 0. Okay, I solved the quadratic equation. Factors of x squared, x and x. Factors of 8 4 and 2. So 4x and 2x. Okay, where should I put my negative sign such that 4x and 2x will give me a difference of positive 2? I should put my negative sign here, which means my negative sign should be in front of 2. Therefore, the factorized form x plus 4 multiplied by x minus 2 equals to 0. Hence, x equals to negative 4 or 2. Okay, since q lies on the positive x-axis, coordinates of q would be 2, 0. And since p lie on the negative x-axis, coordinates of p would be negative 4, 0. Alright? Okay, next let's look at part C. Next let's look at part B. Write down the equation of the line of symmetry. So very simple, I just have to find the middle point between the x-intercept. So in this case, I would have negative 4 plus 2 over 2, where that will give me negative 1. Therefore, x equals to negative 1. Okay? And state the coordinates of the minimum point. So when x equals to negative 1, y would equal to negative 1 squared plus 2 times negative 1 minus 8. And that would give me negative 9. Therefore, coordinate of minimum point would be negative 1, negative 9. Okay, let's look at part C. Find the equation of the additional straight line which must be drawn on the graph in order to solve the equation x squared plus 4x plus 1. Okay, so by comparing x squared plus 4x plus 1, I can split this into x squared plus 2x plus 2x minus 8 plus 9 equals to 0. So I move all of my terms that are not involved in the equation of this curve to the right hand side. That gives me x squared plus 2x minus 8 equals to negative 2x minus 9. Alright? So therefore the equation of the line would be y equals to negative 2x minus 9, which is the answer for part C. Okay, then let's look at the last part. A line L cuts the curve at x equals to negative 5 and at x equals to 1. Find the equation of line L. Okay, so from here, what we can find from this information is the gradient of the line. Okay? Before that, let's find the coordinates of the 2 points that this line has cut. So I have to substitute x equals to negative 5 and x equals to 1 into the equation. So y equals to negative 5 squared plus 2 times negative 5 minus 8, which equals to 7, okay? And y equals to 1 squared plus 2 times 1 minus 8, which equals to negative 5. Therefore, gradient would equal to 7 minus negative 5 over negative 5 minus 1, which gives me negative 2. And lastly, let's just substitute in the values of x, y, and m into the equation to find c. Okay, so I have y minus 7 equals to negative 2 times x plus 5. Okay, so y equals to negative 2x minus 3, which is the answer for question 9, last part. Okay, next let's look at question 10. Question 10 requires me to find the distance between the two flags A and B. Okay, right off the bat, with the information annotated, I realized that I have this right angle triangle over here. Okay, using Pythagoras theorem, I would be able to find EC. Okay, so EC squared plus BC squared equals to EB squared. Therefore, EC squared equals to 50 squared minus 40 squared. So EC equals to square root. EC equals to square root 50 squared minus 40 squared, which equals to 30. Okay, and next we know two of the sides for this right angle triangle. Okay, so I would be able to form the equation ED squared plus AD squared equals to AE squared. Therefore, ED squared equals to 41 squared minus 40 squared. So ED equals to square root 41 squared minus 40 squared, and this would give me 9. Okay, so DC equals to EC minus ED. So I have 30 minus 9, which gives me 21. Okay, which is the answer for question 10. Okay, let's look at question 11. Alright, next let's take a look at question 11. Question 11 states that a vertical pole AB stands on a horizontal ground BC. Okay, CP and CQ are two wires connecting the pole and the ground such that QB equals to 6 meters and angle BQC equals to 79 degrees and angle BPC is x degree. Okay, if tangent x is 15 over 8, they want us to find cosine x without evaluating x, leaving your answer as a fraction in the lowest term. Okay, so if they are referring to tangent x, the angle that they are looking at should be, the triangle they are looking at should be this triangle over here. Okay, so for tangent, it would be opposite over adjacent. That would also mean that BC over PB equals to 15 over 8. Okay, and if BC over PB is 15 over 8, are we able to find PC? Yes, we could, because to find PC squared, it would be 15 squared plus 8 squared. Okay, so PC would equal to square root 15 squared plus 8 squared, where I would have 17. Okay, cosine x would equal to adjacent over hypotenuse, which in this case would be PB over PC, hence 8 over 17, which is the answer for part A. Okay, and they say to find the distance y. Alright, okay, so before finding my y, I need to know at least one of the actual length of the side of triangle BPC. Okay, so by looking at all of the details given to me, I would be able to find a side BC using the triangle BQC. Okay, so we have tangent 79 degrees equals to BC over QB. Okay, therefore BC would equal to 6 multiplied by tangent 79 degrees. Okay, if it's 6 multiplied by tangent 79, we know the actual length of BC. Okay, and we know that BC over PB is 15 over 8. So I am able to write 6 tangent 79 over PB equals to 15 over 8. Therefore, PB equals to 8 multiplied by 6 tangent 79 over 15. If I were to key into my calculator, I would have 16.462. Okay, and let's not forget PB is y plus 6 equals to 16.462. Therefore, y would equal to 10.462. If I approximate to 3SF, I would have 10.5 meters. Okay. All right. Lastly, let's look at part C. Two possible dimensions of triangle PBC in meters if P and C are variable points on the pole and the ground respectively. Okay, so they are just asking if tangent x equals to 15/8. All right. What are the possible dimensions? So from part A, we have found that the possible dimension could be 8 meter multiplied by 15 meter multiplied by 17 meters, right? With that, we just need to ensure that the ratio is the same. Therefore, I can also have 60 meters multiplied by 30 meters multiplied by 34 meters. Okay, so that is the answer for question 11. Okay, let's look at question 12. Question 12 shows a layout of Mr. Tan's living room with dimension 3 meters by 3.6 meters by 4 meters. Okay, and in figure 2, it shows a 2D diagram with Mr. eye level at X, which is 1.24 meters away from the ground. And the set distance varies from 1.8 meter to 3.8 meters. Okay, and point Y represents the center of the television, which is 1.6 meters above the ground. All right, and Mr. Tan's placed his armchair along MN, which allows him to have an optimal view of the television. He believes that the length of projection XY is 2.5 meters. They want us to find the angle of projection in radians. Okay, so if I were to sketch a rough diagram, if Mr. Tan's eye level is here and Y is over here, okay, this is point X, 2.5 would be here, okay, theta is the length of projection and the opposite would be given by 1.6 minus 1.24, which gives me 0.36. Alright, so with the opposite and the hypotenuse of the triangle given to us, we would be able to find theta. So let's just take sine theta equals to 0.36 over 2.5. Okay, so theta would equal to sine inverse 0.36 over 2.5. If I were to key in the calculator using radian mode, I would have 0.145 radians when approximated to 3 significant figures. Okay, next let's look at part B. If Mr. Tan chooses to place the armchair at the furthest possible optimal distance, they want me to find Tx. Okay, so it is at the furthest possible distance. D would be 3.8. So this distance, if X is over here, this distance would be 3.8 meters. They want me to find this distance over here. Okay, let's take note that this is slanted inwards. Okay, if I were to create a right angle triangle over here, okay, and let me name this random point along TW as point P. Let me name this as point U. Let me name this as point C, for example. Okay, so CX, I can also see it here at W and the foot of X. Okay, so am I able to find W and the foot of X? I could, because I know that WM is 1.8 meters. Okay, and I know that M to the foot of X would be given by 4 minus 3.8, which is 0.2 meters. Okay, so To find w to the foot of x, I have square root 0.2 squared plus 1.8 squared. Okay, and that would give me square root 3.28. Alright, so since I have cx, I can find ct by taking half of 3, which is 1.5. I can find tx, which is square root 3.28 plus 1.5 squared. Okay, if I were to key into my calculator, I would have 2.53 meters when approximated to 3SF, right? Okay, then they want me to find PXT. PXT would be given by this degree over here. Since we have TX, okay, we have PT, we can use cosine rule to find angle PXT. Okay, so to build the cosine rule, I have 3.6 squared equals to 6.3776, which is the square of 2.53 plus 6.3776 minus 2 times 3776. Sorry, 2 times 6.3776 multiplied by cosine angle PXT. Okay, so when I simplify, I have angle PXT as about 90.9 degrees when approximated to 1 decimal place. Alright, then let me look at the angle of elevation of y from z. Okay, so at 3.8, I would be able to sketch the diagram over here, okay, where this is 0.36 and this is 3.8, and I want to find my angle of elevation over here. Okay, so I have tangent theta equals to opposite over adjacent, so 0.36 over 3.8, so theta would equal to 5.4 degrees, okay, when approximated to 1 decimal place, which is my answer for question C, part 3. Alright, next let's look at question C. Alright, sorry, the previous part was our section. Question B. Okay, let's look at question C. Given that the angle of elevation of y from x is 12 degrees, will Mr. Tan still have an optimal view of the television? Okay, so back to the same triangle again, but in this case, we have the opposite, which is 0.36. We have the degree over here as 12 degrees. Alright? And we want to find this. Okay, so again, we take tangent 12 equals to 0.36 over distance, right? So distance would equal to 0.36 divided by tangent 12. When I key into my calculator, I would have 1.69 meters. Okay, since 1.69 meters is less than 1.8 meters, okay, Mr. Tan will not have an optimal view. Of the television. Alright, okay. Alright, I hope you understand my explanation. It has been a very long process of going through the paper. Thank you for sticking with me to the end. I hope I see you next time. Bye bye.